Okay, let's take up yesterday's homework question. So, first what is my vertex? Looking at this, what's my vertex? Leandro. Perfect. Okay, does this open up or open down? Andy? Up, because it's positive 2 in the front, right? So that's why when I made my grid right here, I positioned it lower so that because I know my parabola is going to be opening up. So I left more room for the y. So 3, -4, 1, 2, 3, 4. I have my vertex right here. Okay. Okay. And then from this point, I have to grab. I have to go. So I can do the step. I can do the step method. So 1, 3, 5. Remember, I'm timesing my steps. I'm gonna times it by a. What is my a value here? 2. So I'm gonna times 1 by 2, times 3 by 2, times 5 by 2. So my steps are gonna be 2, 6, and 10. So these are my steps. So I'm gonna go over 1 and then up how many? 2. Alright, so notice I'm doing on both sides because it's symmetrical. I'm gonna go over 1 and up how many? 6. 1, 2, 3, 4, 5, 6. And then I'm gonna go over 1 and up how many? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Somewhere here. Okay. Okay. And then how do I connect the dots? Should I use a ruler? Because what shape am I trying to draw?
Well, you could use a protractor.
You don't want to because it's a nice smooth curve. I'm trying to draw a parabola, so even if it doesn't look perfect, I should like if like for example I have like something like that. Is that good? Do you think you'll get the mark? No. If I do this and then suddenly my parabola turns inwards like that, is that a good parabola? No. Okay. So your parabola is supposed to move outwards. Right? So a little like this, outwards like that. Okay, so that's what your parabola should look like. Okay. List the transformations. Okay, so let me just rewrite it down here. Y equals 2 x minus 3 squared minus 4. Okay, what does the 2 tell us? William? Stretch by 2. Good. Okay, what does the minus 3 inside the bracket tells me? Okay, William, why don't you answer the whole question? Right 3. And then what about this minus 4 at the end? Yep. Down by 4. Perfect. And notice he said down by 4 and not down by -4. Just like with the negative stretch, you can't stretch something by a negative factor. You can't move down -4 spaces. Okay, so when you write it in writing, make sure the English makes sense too. Okay. How many of you got this graph? Give me everybody. Okay. Good. This is yesterday's homework that you did. Yeah. Okay. So let's do this one now. This one, what is my vertex? We're taking up yesterday's homework. So Gavin. -1 and 3. Does my parabola open up or open down? How do you know? Right, because of this negative in the front. So that's why, again, I drew my axis like this, so I have more room to draw my parabola downwards. So negative 1 and 3, okay. And then from there, I'm going to do my steps. So again, my steps. Oops. It's the last period of the day. I can't tell my left and right. Thank you. Just seeing if you guys were paying attention. Okay, so now it's on this side. Yeah. Okay, so I'm doing my steps times A. What's my A value here? William?
1.5 or 0.5 or
Negative, right. Negative 1 over 2 or negative 0.5. Okay, so my steps are 1, 3, 5, and I'm timesing it by negative a half. Alright, if you want, because this is just to help us graph, use decimal if you want. Alright, so my steps is I'm gonna go down 0.5, I'm gonna go down 1.5, and then I'm gonna go down 2.5. So 2.5 blocks. So half a box, 1.5 blocks, and 2.5 blocks. Right, so these are my new steps. Okay. Right, I'll give you guys a second. Okay, so yeah, this is yesterday's homework. No, we did the other two. This was homework. Okay, so from my vertex, if these are my steps, 10A, you're gonna help me. What am I gonna do? Go down how much? My first step is 0.5, so half a box. Alright, so it brings me to here and here. And then, Elisa, I'm gonna go over 1 and go down how much? 1.5, 1.5 box. So brings me to here. Right? Because this is half a box and then one more box, so 1.5 box. Okay. And then Rashad. Okay, and then from here I'm gonna go over 1 and go down how many? My third step.
Wait, what are you doing?
My third step?
You're gonna go down how much?
Yeah. How much?
Go down 1. Wait, what did you say?
Okay, so my first step. Oh, I did a very bad job with my graphic. I can tell. Okay, so let's let's pay attention now. Okay, sorry, I made a mistake here. Okay, so I go over 1 and down half a box. That was my first step. And then I go over 1 and go down 1.5 box. That's my second step. And then I go over 1 and now I go down 2.5 box. Okay. Right? Because these are my new steps right here. Go down half, go down 1.5, go down 2.5. Okay, so now I can connect my dots, and there's my parabola. Okay. What was the mistake that I did over here, and then I whited out, William? Right, okay, so I went over by 2 blocks by accident. How did I catch that? Because remember, you're supposed to look for a symmetrical parabola. So when I realized that it doesn't look very symmetrical, I know I made a mistake. Okay. Okay, does that make sense, guys? Okay, so let's talk about the transformation then. Okay. I'm just rewriting the formula. I'm just rewriting the equation back. Okay, so what does this negative half in the front tells me? Jonathan. Reflected over x. What else? It's facing down. Okay, facing downwards, which is reflected over x-axis. Like it's wider. Okay, what word do we use for wider? Compress. So, Rashawn, what are you trying to do?
Oh.
Uh-huh.
Yeah. Compress.
Compress by
Uh, -1/2.
Can you compress something by a negative factor?
Nah.
So compress by a half. Okay?
Yeah.
Finish off this for me. The +1 inside the bracket tells me to.
Um.
Is it left, right, up, or down?
Oh, that's up. Oh, the one?
Yeah, the one.
Oh, you go down. Oh, yeah.
Inside the bracket. Inside bracket. Elisa?
Oh,
yeah,
sorry.
it's left, right. So is it left or is it right then?
Left.
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 Left one. And then the +3
And then, yeah, +3.
is what?
Oh, what's the vertex?
No, what's the +3? What is it? What's the transformation for it?
Um.
Is it up, down, left, right?
Oh, up.
Right, up 3.
In the bracket. Yeah.
Okay. So for this A right here, don't forget there's two parts, the reflection and the compression. Okay. And reflected because of the negative in the front. Yep.
How come like when you draw the parabola, how come there was arrows at the end?
Oh, you should always have arrows. Your parabola goes on forever.
Okay.
All right. Okay. So how many of you got this as your graph? Good. Okay. So this was yesterday's homework. We just took 10 minutes to take up yesterday's homework. This is the main thing that will get you the most mark for the test next week. So now on to today's lesson. Rashawn, you want to give that up? Uh-huh. Are you sure that's your pencil?
Yeah.
Okay. So page 17, today's lesson. Okay, creating a quadratic model from the data. So example 1, determine the equation in both factor form and standard form that best represents the graph. So what we've been doing for the last 2 days is I gave you the equation and you had to draw the graph. Now what if I give you the graph? Can you come up with the equation? Okay, but it's not so bad. I listed out the steps, so that is not so horrible. Okay, looking at this parabola right here, what is your vertex? Leandro?
3.
And?
-1.
Okay, but take a look at the scale.
I can't.
It's on your paper too. Okay, it's this is 8, 16, 24, 32, -8. So this is 3 and Gavin, what were you gonna say?
4.
It's under the x-axis. -4. Right, so 3 and -4. So make sure when you take a look at the graph, you look at the scale too. I don't have to go by ones. Okay, go by the scale. So every box is 4 right here. Notice the scale. Okay, so can we put the H and the K in this format? Okay, so Sydney, what would it be? X. Yeah. Right. Good. Okay. What I don't know is the A. Okay, because I don't know if this, just by looking at it, I don't know if it's stretch or compress. I know the vertex, so I can easily put it in this form. So I need to figure out A. Kind of. So you would, remember, this is vertex form. So once you know the vertex, you can finish part of the equation. So now how do I find A? I find A by substituting a point into this equation. So looking at this parabola right here, do I know another point? Gavin?
2 and 0.
Yeah. Okay, 2 and 0. That's a good point. Another point that I could use. Yeah.
4
4 0. Yeah, I can do that too. Can I use the vertex? No, because if I use the vertex, everything is going to be 0. Okay, we used the vertex already. So we need to use one other point. It could be this point. It could be this point. Okay, it could be any of those points. So let's say I use this 2 0. Okay, which means this is my x, this is my y, and I'm going to substitute that into the equation. So y is 0. Yeah, x is 2 minus 4. So let me just write that. Okay, so I substituted the 2 and 0, the other 1 point on the parabola, and I have this. Okay, notice in my whole equation, only a is unknown. So it's just simple algebra that I have to do to solve. So BetMass. Who's good at mental math? Okay. Jonathan, what's 2 minus 3?
-1.
What's negative 1 squared?
1.
1. Yeah. Right. A times 1 is just A. Yeah, and then so that means when I move it over, so I basically have this A minus 4. So what is A? Yeah, move.
Yeah. 4.
Okay. And there you go. A equals 4. So I know what A is now. It's actually stretched by 4. So what is my equation? Y equal, Gavin.
4
Yeah,
bracket x minus 3 bracket squared minus 4.
perfect.
Yeah.
Okay.
See something?
No, this is exactly it. Okay. If you look at the graph right here, but miss, why is it 4? I thought it was 1 because if I do the step method, it's over 1, up 1, over 1, up 3, over 1, up 5, which is what I see right here. So why is it 4? Sydney? Right, because my scale right here. If you recognize that on the test and you say it's 4 because it's following the step pattern, you'll get the mark for it too. So if you can recognize that, you don't have to do this. Okay. And then step 5. You guys are planning something, eh?
He's blocked by both of his chair.
Uh-huh. Okay. And Tayden, where's your booklet?
Oh, my booklet?
Let's take it out.
It's like, you know, like what an eidetic memory is? Like I just took a snapshot in my mind of all the pages and I'm just like,
Let's get it from your bag. Okay. This word. Expand to standard form. Expand. Where have we seen this word? Last chapter, right? And technically, you saw this question in the last test. Okay, it's nothing that you don't know. It's you're just expanding. So x minus 3 squared. Remember from the last chapter, what do we have to do to expand this?
You have to do it 2 times and then you have to use FOIL.
FOIL, right? Okay, so you're not just x squared minus 9. Remember, you have to do FOIL. So first, outside, inside, last. Yes, the last chapter is still related to this chapter. So 4 bracket x times x, x squared. Good. X times negative 3, negative 3x. Negative 3 times x, negative 3x. Negative 3 times negative 3 plus 9. Okay.
is that it?
No. and then simplify. So 4 x squared minus 6x plus 9 minus 4. Alright, this was last chapter when we did algebra and the expanding. Well, it doesn't mean you don't need to, doesn't mean we forget about it, because remember there is still the final exam and it's still going to come back. Gavin, what do I do with this 4? Yeah, times everything inside the bracket by 4. So 4x squared minus 24x plus 36 minus 4. We did FOIL. Alright, am I done?
No, you can simplify.
Yeah, these two I can. So in standard form, it's 4x squared minus 24x plus 32. Okay, yeah, that's it.
Is that it later?
Alright. Is this, remember one of the questions from your last test? It was asking, is this the same question as, is this the same equation as this?
Yeah.
Yeah. This, what do we call this format again? Oh, no. Vertex. So vertex form tells me the vertex. What do you think standard form tells me?
Standard.
What else other than the standard? Mingyang, standard form tells me what in my graph?
The A, which is the stretch type compression.
Okay, yeah, it tells me A. Also, something else. Huh? Oh, we'll get into that tomorrow. Okay, so vertex form tells me the vertex. Standard form tells me, what is this number here?
32.
Take a look at the graph.
Oh,
Yeah, the y-intercept. So standard form tells me what the y-intercept is. Tomorrow we do factored form. And guess what the factorial tells us? Alright, we'll wait for that for tomorrow. Okay? Okay, let's try this one then. Tayden, do you have your package out now? Alright, can you read example 2 for us? Yeah.
Okay, while on vacation, Steve filmed with Swift Diver. He analyzed the video and reports the height and top of the diver in the scene below. Determine an algebraic model for the data. One for the diver, 5 meters above water.
Okay, thank you. Okay, so this is what Steve does when he's on vacation. He analyzes the video. Okay, so if I were to graph this, what goes on the bottom, what goes on the side?
the time goes on the bottom.
Good.
And the height goes on the left side.
Perfect. All right, and the height goes on the side. Yes, time always goes on the bottom because that's your independent variable. Okay. So what number is this right here?
0.
What number is this right here? 0. Okay, this corner is always 0, 0. Okay, and then looking at my table right here, I need to go to 2, so I can space it out. So let's do okay, let's do okay. Let's do 1, 2, 3. So every 4 boxes. I'm doing every 4 boxes. That's 1, 2, 3, 4 like that. Okay. Okay. So this is a diver. So what's the maximum I need to get to for here for my y-axis? William? 35, right? Because that's my vertex right here. This is the highest point. This is the so 0, 35. So let's go by 5s then. 5, 10, 15, 20, 25, 30, 35. Right? I have that there. And then I can plot the rest of the points. 0.5 and 33.75. Up here. 1 and 30. 1 and 30. 1.5 and 23.75 about right here. And then 2 and 15 about right here. Right? So when I graph it, it looks something like this.
Is this a linear?
What are we focusing on this unit? Parabolas, right? So you want to draw a parabola. Okay. Why didn't I draw a T graph? Why did I draw an L graph instead of a T graph? William?
Because we can't really go into negative signs.
Right, we can't go back in time. So that's why I only did that part. But I don't see a parabola here. I see a curve. Where is my parabola? So technically, yes, my parabola is something like this. But because it doesn't make sense to go into negative time, that's why we're only looking at half the parabola. Equation-wise, though, it's still the same. Right? So, so based on what we did in this example over here, right, we do follow the same steps. Step 1, find the vertex. Step 2, put it in vertex form. Right? So looking at this is the highest point of my diver. So this is my vertex, 0, 35. So 0, 35. Can you put it in vertex form? Y equals, yeah.
Y equals x squared
Good.
plus minus 0, so plus 35.
Good. Okay. I just wrote it, but you're totally correct. But what is minus 0? It's nothing, right? So it's just gone. So technically, the equation of this line is just ax squared plus 35. Okay. What was the third step on the left side? The third step was to do what? Yep. Yeah, substitute a point. Which point should I use? Which point looks like a nice point to use? Sydney? Okay, but remember, I'm given a table right here. So I could use any one of these points on the table. So 1 and 30 sounds like a nice point to use. I don't want to use these ones because these ones have decimals and so forth. I can use 2 and 15 as well if you want. Alright, so 1 and 30 sounds like a good one to use. So y is 30. Okay, a is what we try to find out. X is 1. And then plus 35. Okay, so this is the point that I want to use. The 1 and 30. This point. Right, so I substituted that into here. Okay. 1 squared, that's just 1. So I have 30 equals a plus 35. And so what is a? Gavin?
Minus 5.
Yeah. So what's my equation? Willem?
Y equals minus 5x squared plus 35.
Yeah. X squared plus 35. And does it make sense that my a value is negative?
Yes.
Yeah, because my parabola opens downwards. So if you show a diver diving down, you get a positive A value, it doesn't make sense because you cannot dive upwards. Okay. So when will the diver be 5 meters above the water? So if I were to extend this, something like that. All right, I'm trying to figure out what is this point right here. When it's 5, when does it reach 5 meters above the water? Right? Other than looking at graphically, what can I do mathematically? Yeah. Right. Yeah, Ethan? Oh, yes, y, for y. That's right, because this is your height. So this is your height, so which means y is 5. So sub in y for 5. Negative 5x squared plus 35. So when you move the 35 over, 5 minus 35, you get negative 30. Right? Divide that, you get 6. And when you square root 6, what do you get?
36.
Square root 6. You get about 2.5. All right. So what's my therefore statement here? What's my therefore statement here? Yeah, it's a longer lesson today. What's my therefore statement? Andy.
Therefore, I don't know.
What about Jaden? Okay, Leandro?
It'll be 5 meters above the water at 2.5.
2.5 seconds, right? After 2.5 seconds, I was hoping to get the units from you guys. After 2.5 seconds, the diver,
Can I say the other way around?
yeah, will be at 5 meters above the water.
What are you doing?
Okay? So I know today's lesson is like super long, but it's because we're doing the backwards. We know how to graph the parabola now. Now we have to do from the parabola finding the equation, and to find it, there's a lot of algebra involved. Uh, it's not easy, but after practice, then it makes sense. Okay, so try these questions here. Okay, on the next page right here, you don't have to do every single question. If you want to, if you don't pay attention, then yes, do every single question. Otherwise, just do these ones: 1H, 2H, 3, 4, 7, 8, 9, and 10. Because if I just tell you to do every single question, you're gonna stop after question 1. Alright, so I'd rather you do all the different types. Answers are on the back of the package on page 29. Our answers. So make sure you check. Okay, check your answer. Huh? Tomorrow's the last lesson of this package. Review. Yeah. Okay.